All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're going to move in and do moment of inertia now. Moment of inertia in statics is probably one of the more abstract things. We're going to do a handful of videos really quick on how we can do this with integration. We have other methods that we'll tackle down the road, but this is where people typically start out. So let's get a couple examples integrating everything. So determine Ix and Iy, moment of inertia about our x-axis and y-axis for our objects shown. And then I've written out our steps. So to do this, we're going to say, let's create an equation for y in terms of x. So you get like a y equals something statement. We'll do the same thing for x in terms of y, get an x equals statement. So let's just stop there and we'll get these set up. So we're trying to work through that. I know I have a line, right? Just a linear line on this. I know the equation for a line is y equals mx plus b. And we'll work with that, and then we can rearrange once we get this filled in to get our x equals equation. Well, what's b in this? B should be the intercept of the y-axis. B is right here. If we're 5 inches up, b is 5. So b equals 5. M is our slope, just our rise over run. M is, well, I go down 5 and over 4. So negative 5 over 4. My slope here is negative 1.25. Which means my equation for y, I really should be writing this as y equals negative 1.25x plus b plus 5. Or I could rearrange that and solve for x, and I get my x equals, which is my second step in here. Rearranging that, I would get, this is going to give us that x equals 4 minus 0.8y, which would be our second equation here. From there, we're going to come in and start drawing pictures out for everything. So we'll do these one at a time as I come through here. Let's get Ix set up first. So I want to make a new triangle. I'll just put it down below. I have a triangle that I'm working with that's 5 tall and 4 wide. This point right here, we're still going our y-axis and our x-axis. This was point 4 up, or 4 over, 5 up. We have our piece here. I want to add in a differential area that goes parallel to our axis of interest. So if we're going to tackle here, Ix. So parallel to my axis of interest should be horizontal, Ix. We'll come in and put this piece in here. So I'm going to show this just in general, somewhere in the middle of my object. I have a differential strip that looks like that. Starting at the y-axis, I want to primarily, okay, we have little pieces that aren't, but to cover up just the object of interest, our triangle here. So we have that. My width of this should be in the x direction. Well, that's just at any point in here. I'm at x. I am x wide. And my height in this, if this is infinitely small, let's call that a distance in the y, dy. And I can work with that to then come in and say, well, let's find my next piece. I got Ix, I drew a horizontal rectangle. Let's find the area of that differential area in here. So my dA, my differential area, should be base times height, x dy. We're going to end up integrating this. I probably want to get to y dy if I actually come in and integrate that. So let's sub in my x equals statement. This is the same thing as x is 4 minus 0.8 y times dy. So I have my dA in here. I could then come in and say, my next step, I can find Ix. I'm going to integrate for Ix. Ix is my integral of y squared dA. Y squared dA, which I have all these pieces. Ix equals, if I'm writing this as an equation, I would say, well, let's fill in what we know. Ix should be my integral, and I'm going to go from my smallest y value, because I'm moving this differential strip. My smallest one will be down here at 0, 0, up to my largest. The top piece here is 5 of y squared, we'll leave that as y squared, times dA. And I know dA is 4 minus 0.8y dy. times 4 minus 0.8y dy. Which I can then try to integrate that. I should get here that this is ix equals 4y cubed over 3 plus or minus 4y to the 4th over 20. And we're evaluating all of that from 0 to 5. Which is going to give us that my ix value is 41.7. Ix equals 41.7. If we think of our units, these don't make sense. Don't get hung up on this. I have a y distance squared times an area. That'd be a square distance. Distance squared times a square distance will get me distance to the 4th. So inches to the 4th. The units here, don't try to wrap your head around that. It's not going to work out great for you. Moment of inertia is loosely telling us how resistant is something to bending for our application. There's ways we can work through that, but a bigger I value means it's going to be harder to bend our object. This is going to show up a ton as you move into things like mechanics and materials, uses I over and over and over. But right now in statics, we just need to be able to do it. That'd be one of our pieces in here to get Ix. I can just repeat that process and come in and say, well, I could also make another triangle in here. We'll show our y-axis. We'll redraw that triangle. And our x-axis, x and y. This would be Iy that I'm finding over here. My highest point here was 5. My widest point was 4. And again, I can make a differential strip that goes parallel to my axis of interest. If I'm looking at Iy, y is my axis of interest. Parallel to that would be a vertical strip in here. At any point that I look at that, as I move it left or right, my height will always be y, and my width is always dx on that. So I drew for Iy, I drew a vertical rectangle. Let's find the area of this. My dA this time, my differential area, should be base times height, or y dx. Which, to make our integration easier, let's get that to x dx. We can come in and substitute in here. This is really, dA is y negative 1.25x plus 5 dx. And we have dA then, which gets us to where I can set up my integral. If I'm looking for Iy, I want x squared dA. So my Iy should be my integral of x squared dA, which I can sub in here and get everything in terms of x dx still. So Iy is my integral from my smallest x value, 0, to the largest is 4, of x squared times dA, negative 1.25x plus 5 dx. Which I can integrate that. We can go through the work, or we could probably just use like an online solver here and get that my Iy is going to be equal to 26.7 inches to the 4th. Which would be our final answer for Iy. Hopefully this was a useful video for us. If it was, stick around, watch more videos. Let's get you an A with JJ.